In this guide we are going to learn the basics of using the training builder in SimLab Composer to create an interactive VR experience. First, we are going to overview the training experience that we are creating and explain our goals. Then we will talk about the training builder's node system and how it can be utilized to create intricate and simple interactions. We will then create a simple event system that we will evolve into triggering multiple responses, and then take a look at integrating animation and animation sequences within the VR experience. We will also talk about the use of variables and how they can be of great assistance, even with simple systems. Then, we will explain the use of scene states and how it can be used to change objects' attributes within VR. Throughout this training, we will be using the SimLab Academy, which is an integrated library that will help you follow up with this guide. From the library panel to the bottom, select SimLab Academy, then select VR and click on the Training Builder Basics. Here, you will find multiple items that we use consequently as we progress through the guide. The first item to the left will run the video of this guide, so let's skip it and go to the next item. The item named Load Environment is going to be our first step. It will load a scene in SimLab Composer that we will use as the surrounding for the VR experience. Drag and drop step 1 onto the 3D area or double-click it to activate it. As you can see, this is a 3D environment of a technical lab which is suitable for the task at hand, and it already has the lighting and materials set up, so we do not need to worry about it, and we can focus on the training material itself. Go to the second step and import the subject of this training, which is a UPS unit. Press N on the keyboard to activate snapping to object, then click on the table to place the UPS on top of it. Rotate it and adjust its position to be close to the edge of the table. What we will be doing in the training builder is create a VR experience where we will remove the 4 screws to the side of the unit, then remove the cover, and then we will replace the currently placed fuse with a new one from the library. We will also be using the power drill or the screwdrivers to loosen the screws. Open the training builder. The training builder is comprised of a free-moving working area, where you can pan and zoom in and out, and a top panel that includes all the nodes that you can use in the training builder. Let's go over the nodes that interest us in this guide. To the far left, in green, you will find the input nodes, which enables you to attach objects and elements in SimLab Composer to the training builder. Next, you will find the event nodes, which are used to dictate the interaction between elements in the VR, and based on that interaction, responses are triggered. To add a node to the working area, click it to place it at the center of the working area, or drag it and drop it in the position you choose. Let's add a Scene Start event. The Scene Start event will trigger any responses you attach to it once the VR experience starts. Add and apply Scene State response. Scene states store objects' attributes and can be used to change their position, material, and visibility, among other things. Now attach the event node to the response node by dragging and dropping the execute channel from one to the other. Now add a scene state input node and attach it to the response to specify which scene state to apply. This simple system that we created will apply a certain scene state once the VR experience starts. Let's look at another example. Add a node entered node event. This event will trigger responses once 2 specified objects intersect during the VR experience. To specify which objects this event handles, click on the Attach button in the Scene Node channel while an object is selected in SimLab Composer, or you can add an input node and attach the object to it, then attach it to the event. Using an input node over directly connecting the object to the event node can be useful in cases where you need to use the same input node in multiple events, and you want to avoid reselecting the object every time you need to use it in the training builder, or to keep the node's network organized and simpler to read. Add a play sequence response and attach it to the event. As for the sequence, you can either directly connect it to the response, or add a sequence input node then attach it to the response. Now that you're familiar with connecting nodes in the training builder, let's delete the nodes we created and start working on the training at hand. For this VR experience, the first thing the trainee needs to do is to unscrew all 4 screws, and to do that, we're going to give him a power drill to use, so let's first add the power drill from the SimLab Academy to the scene. Go to step 3 and drag and drop it onto the 3D area. Place the power drill on the table using the N key on the keyboard. The event we need to create involves the Phillips bit and the screw, and once those two objects intersect, we need the screw to become loose so the user can remove it. Add a node entered node event, and with the drill bit selected, click on the Attach button. Now select the screw at the top right corner, and attach it as the second object in the event. Now what we need to do is to add a response that will allow the trainee to grab the loose screw, so let's add a change grabbable state response, and make sure you select the parent node for the screw and not the screw itself, since we need to reserve the lower level to create animation later on in the guide. Now click Attach. Connect the event to the response we just created, and make sure that the grab enabled is set to true and not false. Before we test out the VR experience, we need to first make the drill grabbable, and since we want to allow the user to use it at the beginning of the experience, we are not going to use the training builder, but we're going to set its state to grabbable. With the drill selected, go to the Interactions menu and select Make Grabbable. Click the check mark to confirm your selection. Notice that the icon for the power drill has changed to a purple hand, indicating that it is now a grabbable object. From the SimLab VR Viewer menu select Show in Viewer, then select Virtual Reality if you have a VR headset, or Desktop mode if you do not. Click on the ground in a location close to the UPS unit to snap the starting position there, and to determine where the user will be located at the beginning of the VR experience. Click the check mark to start the VR viewer. In VR, use the trigger button on the controller to grab objects, while in desktop mode, press H on the keyboard to show the hand, and then use it to grab by left-clicking the mouse. Notice that the screw was ungrabbable until the power drill intersected it. The remaining 3 screws cannot be grabbed yet, which is what we're going to work on next. Go back to SimLab Composer and open the Training Builder. Select the nodes we created earlier, then press Ctrl and C, then Ctrl and V on the keyboard to duplicate them. Now we're going to replace the attached screw with a different screw. Select the top left screw and click Attach to replace the old one. Go up one level in the object tree to select the screw's assembly, and attach it in the response node. We're going to repeat this step for the 2 remaining screws. Now we have 4 systems that will make the screws grabbable once they intersect with the drill bit. What we are going to do next is to enhance the visual aspect of the created interaction by adding animation. Let's begin by creating an animation for the first screw. Go to the Animation tab in the bottom panel and make sure that the geometry level is selected and not the assembly, since we used that for grabbing and we do not want to have a conflict, which is a good practice in general when dealing with animation and grabbing. Now move the time slider to frame 15, and then move the screw outwards slightly by a value of around 0.02. Now rotate the screw 120 degrees counterclockwise. Move the time slider again to frame 30 and move the screw 0.02 units outwards and rotate it by 120 degrees in the same direction. Move the slider one last time and move and rotate the screw similar to what you did before. Now we have a decent animation that we can use for the screw loosening while the drill is intersecting with it. To use the created animation in the training builder, we need to store it as an animation sequence. To do so, select the created keyframes and click on Create Animation Sequence. You can enable the reverse option to create an additional sequence where it animates backwards, in case you need to tighten the screw. Type in the name S2 since the object that we're currently working with is named Screw2, then click OK to finish the creation process. Now we need to create an animation for the drill rotating. Select the assembly named Rotating Head and similar to before, set the timeline to frame 15 and rotate the head 120 degrees counterclockwise. Move the time slider to frame 30 and rotate it 120 degrees in the same direction, then do it again at frame 45. Now that we have an animation that matches the one we made for the screw, you can go ahead and select the created keyframes, then click on Create Animation Sequence. In the dialog, type in the name drill and click OK. Open the Training Builder. Add a play sequence response and select the S2 animation sequence from the Sequences tab at the bottom panel, then click Attach. Connect the Screw 2 event to the animation sequence response. Add another play sequence response and attach the drill animation sequence to it, then attach it to the same event. Now we have a system where when the screw intersects with the drill bit, the screw will become grabbable, and the screw and the drill will rotate, but we need the screw to be grabbable after the animation ends and the screw becomes loose. To do that, add a sequence-ended event and attach the drill sequence to it, then attach it to the grab response. Now the system became, when the screw and the drill bit intersects, both of them will rotate, and once the animation is done, the screw becomes grabbable. Now we need to proceed with the same steps to implement animation sequences for the remaining screws. Select the top left screw and create a counterclockwise animation for it. Do the same for the remaining screws and make sure you name them properly to keep track of them easily in the Training Builder. Go back to the Training Builder and space out the node system slightly, to make room for the new nodes. Add a play sequence response and attach the S3 animation sequence to it, then attach it to the Screw 3 event. Duplicate the response and attach the drill animation sequence to it, then attach it to the event. Similar to what we did earlier, add a sequence-ended event and attach the S3 sequence to it, then attach it to the grab response. Notice that we are now connecting the screw's animation to the sequence-ended event, and not the drill, since we are using the drill animation 4 times and we do not want all screws to become grabbable when it ends, so instead we attach each system's animation sequence to the sequence-ended node, to have the screws become grabbable once their unique sequence ends. Follow the same steps to have 4 systems that have unique animation sequences attached to each one of them. Go to the SimLab VR Viewer menu and select Show in Viewer to test out the results. Now we can use the power drill to loosen and remove the screws. Next is to remove the cover that is being held by the screws. Go back to SimLab Composer. As you can see, we need to have all screws loosened up before we can remove the cover, so we need to find a way to store information in the Training Builder. This is where using variables comes in handy. In the Training Builder, click on the Variables icon, then click on the Add Variable icon. Type in the name S1, and for the initial value type in place. Make sure that the variable type is set to string while doing so. Create another variable and name it S2, and set the initial value to be in place. Create two more variables named S3 and S4 for the remaining screws. Now we need to add a change variable response and attach it to the screw 2 event. In the response node, set the variable to S2 and the value to loose. What we have now is a system where when the drill bit touches the second screw, the variable named S2 will be set to loose. Duplicate the variable response by pressing Ctrl and C, then Ctrl and V on the keyboard, then attach it to the screw 1 event. Make sure you set the variable to S1 and the value to loose. Keep in mind that you must use the single quotation mark when typing in the value of a string variable. Duplicate the response 2 more times and attach it to the remaining events, and make sure you set the variable to each screw respectively. Now that we have set up the variable responses, we need a way to make the cover grabbable, once all the variable values are set to loose, in the VR experience. From the Nodes panel, add a Compare Variable Value node. This node monitors a variable, and once its value changes it can execute responses similar to an event node. It can also enable or disable events based on a variable's value. Set the variable in the node to S1 and the value to loose. Duplicate the node, and this time set the variable to S2 and also the value to loose. Create a second and a third node and set their variables to S3 and S4, and both of their values to loose. Create an AND node and connect its first Boolean channel to the first Compare Variable Value node, and then connect its second channel to the second node. Duplicate the AND node and connect its Boolean channel to the 2 remaining comparison nodes. Add a third AND node and connect previously created AND nodes to it. Finally, we need to add the Change Grabbable State response, then attach the cover to it and set it to true. Then attach the onTrue channel from the AND node to the Execute node in the response. What we have now is a system of nodes where when all the screws intersect with the power drill, the 4 variables will be set to loose, and once they are, the cover will become grabbable. Test out the VR experience and see how it goes. Next we are going to see how we can allow the user to replace the fuse. Select the cover and press H on the keyboard to hide it and reveal the fuse. Select the fuse and in the Training Builder, add a Change Grabbable State response, then click the Attach button to connect the fuse and make sure you set it to true. Connect the response to the AND nodes on True channel. Keep in mind that we can enable the grabbing of the fuse only when the cover is removed, but since it is hidden behind the cover, we don't have to do that. Go back to the SimLab Academy and activate Step 5 by dragging the new fuse onto the 3D area. At the beginning of the VR experience, we want the new fuse to be located on the table, but when it's placed inside the unit, we need it to sit in the right place. To do that, we're going to use scene states. First, we need to set the fuse's position as if it was placed inside the UPS unit. Once you're happy with its position, go to the Scene State menu and select Capture. Disable all the attributes in the Scene States dialog except for the translation attributes, since that is what interests us in this case. You can toggle on the Animate Transform option to get a smooth transition of the fuse being placed in its scene state position. Click on Capture Selection to create the scene state. Go to the Scene State tab, and there you will find a new thumbnail for the fuse. Select the scene state, and change its name to Fuse Placed. If you were to change the fuse's position, and then apply the scene state, you will see the fuse being placed in the stored position at the moment of capturing the scene state, and this is what we're going to use in the training builder to mimic the action of placing the new fuse. Place the fuse on the table, then open the training builder. Add a change grabbable state response and attach the new fuse to it, and connect it to the end node, and set it to true. Now to create the event to place the fuse. Add a node entered node event and attach the fuse to scene node A. Now from the 3D area, select the shell surrounding the fuse and set it as scene node B. Add an apply scene state response and attach the fuse placed scene state to it, then attach it to the node entered node event. Add a change grabbable state response and attach the new fuse to it, then attach it to the event, and set it to false, to make the new fuse ungrabbable once it's placed in the new position. In the object tree to the left, select the cover and press S on the keyboard to make it visible again, then run the VR experience. Now that we are done with replacing the fuse, let's move on to plugging the UPS device to a power outlet. Go back to SimLab Composer, and from the SimLab Academy, activate Step 6 to import a power plug into the scene. Place the plug on the table. Select Create Wire/Rope. In the object tree to the left, you will find two nodes for the rope start and end. Select one of them, and place it at the UPS unit plug. Go to the VR rope tab and lower its width and set its color to black. Now select the other end of the rope and place it at the imported plug. What we need to do next is to place the end attached to the plug within the plug's assembly, so that when the plug moves, the wire would move along with it. In the object tree to the left, drag and drop the rope's end into the fuse's assembly. Now, similar to how we placed the fuse inside the UPS, we need to create a scene state for the plug while it's connected to the power outlet. Rotate and move the plug as if it were plugged into the power outlet. Then from the Scene State menu select Capture. Make sure only the Translate attribute is enabled, and click on Capture selection. Rename the created scene state to Plugged In. Place the plug back on the table in the initial position you want the VR experience to start with. Open the Training Builder and add a Change Grabbable State response and attach the plug to it. Set it to True, then attach it to the node entered node event. Since we are now creating a system that is not directly related to the fuse, let's use a new tab in the Training Builder to keep everything organized. Add a node entered node event and attach the plug to it, then select the power outlet and attach it to the same node. Now add an Apply Scene State response and attach the plugged-in scene state, and attach the response to the event. Select the plug again, and add a grabbable state response and attach the plug to it and set it to false, then attach the response to the event to prevent the plug from moving once it's placed in the power outlet. The last step in the training would be to power on the UPS after plugging it in, and to do that, we need a variable that tells the Training Builder whether the power is plugged in or not. In the Training Builder, open the Variables list and add a new variable. Name the variable Plugged In and set its value to No, since at the start of the VR experience the power is not connected. Now add a Change Variable Value response and set the variable to be Plugged In and its value to be Yes, then attach the response to the event. This will change the variable's value to Yes once the user plugs the device in. Now select the Power button and add a node-triggered event, then attach the selected Power button to it. Since we do not want this event to be always enabled, we're going to use the variable value as an enabler for it. Add a Compare Variable Value node and set the variable to Plugged In and the value to be Yes, and attach its Boolean channel to the event's enable channel. This way, the power button will be interactive only when the variable's value is Yes, which means it will only activate when the plug is inside the power outlet. To notify the user that the power button is pressed, we're going to add a sound effect. Go to the SimLab Academy and activate the last step to load in a sound element. Place the element inside the UPS device since it's spatial and would sound like it's coming from the device in VR. Open the Training Builder and add a sound action response. With the added sound element selected, click Attach and set the type to Play. Now attach the response to the node-triggered event. An additional thing that we can do is to have the screen light up when the button is pressed. Select the screen and click on Capture Scene State and make sure you toggle only the material attribute, then change the screen's material to a lighter color and click Capture Selection. Now revert the screen color to a dark color as if it was turned off. In the Training Builder, add an Apply Scene State node and attach the recently created scene state to it, then attach it to the node-triggered event. Run the experience in VR mode to test it out. This concludes our guide to the basics of the training builder in SimLab Composer, and as you can see, it is very simple and easy to learn and to use, and it can achieve high levels of interactions that are crucial for any vocational or educational training in VR.